Hello, and this is a presentation for my robotic arm for Assignment 1 for MEC4406, being Robotics and Machine Vision. Just want to start out by working out the total of the largest points. So this will give me how long each link needs to equate to. You can see here then I print what that number is. Where I have some random numbers generator. This gives me the 4 points. So the 90 by 90 is going to be my origin point, and then 600 is the maximum it can be. Then I've got inside of here where these numbers are printed out, my link lengths, a function to break the distances between those to give me a straight line for interpolation. This is a function I've created in here where you can see, and then the interpolation equations for each one. After that, you can see it's put into a loop where you works out the sine rule, cosine rule of the inverse kinematics. Where it goes through, works out L, gamma, theta 1, theta 2, and then prints those numbers to the plot down the bottom here. For each iteration, so from point 1 to 2, 2 to 3, 3 to 4, 4 to 5, it continues the loop each time. So once it reaches the counter, starts a new loop and reaches to the end. I like to play this for you now. You can see a few different types of outcomes that I get. So it takes a little time to start. I think that's partially my computer. And then it'll randomly generate these 4 points and move between them. What I did notice is that every now and again I get a addition of 180 degrees to my theta 2, like now, where it's 290. So that's clearly something's wrong. Eventually it just randomly jumps back, like now it's jumped back to what it should be at, like the angle that it should be. I don't know why it's doing that. That's a strange bug in the system somewhere. So there's one cycle. I could run it again and these numbers will be different again. So sometimes that bug doesn't happen and I get a nice run where it's the correct angles each time. Sometimes it shows up for only maybe 1 or 2 points. Other times it happens for the entire loop. I don't understand why it's doing that. I've checked the mathematics over and over and it works. So yeah, this is my code. I've also created a model which I can show you now. So I just wanted to show you, this is the model I made of the robot. You can see there's a board, the graph is, checkers are 600 by 600. You can see here, this is the fully extended position where the laser's touching the far corner. If we were to change these numbers over here, I've got the X and the Y coordinate. If we were to edit these and say we wanted, instead of 600, we wanted, say, 250 in the Y direction. You can see the robot then moves to that position. That's 600 and then 250 in the Y. Alternatively, we could disable these X and Y coordinate and we could simply click and drag the robotic arm to whichever position we wanted to move to on the board. The printed base for the Arduino board, you can see there the servo is mounted on top. The Arduino board can be mounted on the side simply like that with some screws. The laser just gets pushed into cut out for it inside the plywood on the end of it.